Welcome to physics scenario classes. Dear students, today I am going to discuss a question of quantum mechanics that is related with perturbation theory. The question was asked in GATE 2010. The question states a particle of mass m is confined in an infinite potential well. The potential well is defined in terms of potential as it is 0 if x is greater than 0 but less than L, and it is infinity otherwise. It is subjected to a perturbing potential Vpx equals V0 sin 2 pi x upon L within the well. Let E1 and E2 be corrections to the ground state energy in the first and second order in V0 respectively. Then which of the following is true? Option A, E1 equals 0, E2 less than 0. Option B, E1 greater than 0, E2 equals 0. Option C, E1 equals 0, E2 depends on the sign of V0. Option D, E1 less than 0, E2 less than 0. The problem may be depicted in this figure. This is x-axis, this is potential axis, and this is potential well from x equals 0 to x equals L. At x equals 0, the value of the potential is infinity. At x equals L, the value of the potential is also infinity. And from x equals 0 to x equals L, the value of the potential is 0. So this is the potential well. And we are applying a perturbation h prime equals Vpx equals V0 sin 2 pi x upon L. So it is a sine function. So this is the perturbation. Now the first order correction to energy when perturbation is S prime may be written as En1 bra sin 0 S prime ket sin 0. In terms of integral, it may be written as sin 0 star S prime sin 0 d tau, where sin 0 star is conjugate of sin 0. This sin 0 is unperturbed wave function. 0 represents here for unperturbed wave function and n for the state of the wave. So psi1 0 will represent ground state wave function for n equals 1. First excited state would be wave function would be psi2 0 for n equals 2. Similarly, second excited state would be psi3 0. Sin 0 may be written as under root 2 upon L sin n pi x upon L. This is the unperturbed wave function for infinite potential well. For ground state, unperturbed wave function would be just using n equals 1 under root 2 upon L sin pi x upon L. For first excited state, it would be under 2 upon L sin 2 pi x upon L. So first order correction to energy in the ground state would be E11 using n equals 1. It is integral psi1 0 star h prime psi1 0 dx, because here range is from x equals 0 to x equals L, so this is dx. Now in place of psi1 0 we write here psi1 0 star is the conjugate of psi1 0. Here it is no imaginary term, so this is same. So it is root under 2 upon L sin pi x upon L. In place of h prime we write V0 sin 2 pi x upon L multiplied by V0 sin 2 pi x upon L. Now psi1 0, it is under root 2 upon L sin pi x upon L dx. So it becomes 2 upon L V0 here. This is sin square pi x upon L sine 2 pi x upon L dx. Now it is 2v0 upon L. Here divide by 2 and multiplied by 2, so it becomes 2 sine square theta. So in place of 2 sine square theta we will write, because cos theta equals 1 minus 2 sine square theta, so 2 sine square theta equals 1 minus cos 2 theta. As we have divided by 2, so it is 2 sine square theta, that is 1 minus cos 2 theta, 2 pi x upon L multiplied by sine 2 pi x upon L dx. Cancel 2 by 2, so it is v0 upon L, and this is multiply these terms to here, so it is sine 2 pi x upon L dx minus v0 upon L sine 2 pi x upon L cos 2 pi x upon L dx. This is v0 upon L, this is sine 2 pi x upon L dx. So the integral would be, differentiation of cos theta is minus sin theta, so it is minus cos 2 pi x upon L divided by 2 pi upon L, integrated from x equals 0 to x equals L, and here minus v0 upon L. Now divide by 2 and multiplied by 2, so it is 2 sin theta cos theta, that is sin 2 theta, that is sin twice of this, that is 4 pi x upon L dx, integrated from 0 to L. This becomes minus v0 upon L into L upon 2 pi. Cos 2 pi is 1, so it is 1, cos 0 is also 1, 1 minus 1, minus plus v0 upon 2L multiplied by L upon 4 pi, and using limits we have cos 4 pi L upon L, that is cos 4 pi minus cos 0. So 1 minus 1 0, so first term is 0, second term is plus, cancel L to L, then v0 upon 8 pi, cos 4 pi is also 1, cos 0 is 1, so 1 minus 1 is 0, 0 plus 0 0, so E11 equals 0, that is first order correction to the ground state energy is 0. Let us see second order correction in energy. This is En2 equals summation a square of the mod of bra psi m0 s prime ket psi n0 divided by En0 minus em0. Here 0 represents unperturbed state. So, and we have to find second order correction in ground state energy. So for ground state n equals 1, then we will have E12, that is second order correction in ground state energy, equals summation m not equal to 1. In place of n we have to put 1. Psi m0 s prime psi 10 bra square E10 minus em0. This is a square of the mod of bra psi m0 s prime psi 10 divided by E10 minus em0. M is not equal to 1, so m may be 2, 3, 4. So this may also be written as summation, writing m equals 2, then 3, it will 2 psi 20 h prime ket psi 10 mod square, then E10 minus E20 plus square of mod of psi 30 h prime gate psi 10 square upon e10 minus e30 plus. Here we see that in all the terms the numerator is positive because it is a square term, a square of mod. So let us check the denominator. Here e10 is the unperturbed ground state energy, unperturbed ground state energy. E20, it is the unperturbed first excited state energy. E30 is the unperturbed second excited state energy, and so on. Now the eigenvalue energy En is written as n square pi square h cross square upon 2 ml square for an infinite potential wave where the side is L. Here the extension is from x equals 0 to x equals L, so the length is L. For unperturbed ground state energy, that is E1 equals 1 square, that is 1 into pi square h cross square upon 2 ml square. E2 equals, in place of n we put 2, so it is 2 square means 4 pi square h cross square upon 2 ml square. E3 equals 3 square means 9 pi square h cross square upon 2 ml square. Similarly E4, it is 4 square, that is 16 pi square h cross square upon 2 ml square. In this way we have E10 minus E20 or E1 minus E2, this is unperturbed energy, this is this minus this, so it is minus 3 pi square h cross square upon 2 ml square. Similarly E1 minus E3, it is minus 8 pi square h cross square 2 ml square. Similarly E1 minus E4, it is minus 15 pi square h cross square upon 2 ml square. We see that E1 minus E2, it is minus of 3 pi square h cross square upon 2 ml square, this is negative. Similarly E1 minus E3, it is also negative. E1 minus E4, it is also negative. So denominator in each term is negative and numerator in each term is positive. That's why E12 becomes, its first term becomes negative, second term becomes negative, third term becomes negative, and so on. All the terms becomes negative because energy is in a square term, so energy in each state, excited state, is going on increasing. That's why E12 is negative, that is second order correction in ground state energy is negative. In other words, this may be written as E12 is less than 0, and we have already calculated first order correction in ground state energy, it is E11 to be 0. Clearly out of the 4 options, option A is true, it is correct. Thanks.